Hi everyone, my name is Akhila, and in this video, I will be presenting my project on the closest pair of points problem. This is a classical question in computational geometry where given a set of the points in the 2D plane. So we need to find out the closest to each other based on the Euclidean distance. So the main project of the project is to compare the performance of the two algorithms to solve this problem. The brute force approach with the complexity 0 n square and divide and conquer approach with the time complexity 0 n log n. So coming to the execution part, here I wrote the two algorithms in the Python code in my Jupyter notebook called the algo dot. This is my file name. And also, although the Python doesn't need a separate compilation step like C++, I still made sure for both function brute force and the divide and conquer were defined, tested, and executed under the same environment for the fairness. So you can see me running both the algorithms one after the other. Each algorithm reads from the same list of the randomly generated points so that the comparison is completely unbiased. So now let me explain about the input points which are generated. Here I used a simple code called the generate points n creates n distance random points, each with an xy coordinate between the 0 and 1000. I use the Python built-in random module and store the points as the object inside a list. To keep it consistent, I generated the random set once and then used a copy of the same dataset for both the algorithms. That way, any difference in performances comes purely from the algorithms logic, not the data. So now coming to the algorithms, this is let me show me a quick look on how each algorithm works. Now coming to the brute force algorithm, this one is super straightforward for every point it checks the distance to each point and keeps track of the smallest one. It is simple and accurate. It is quickly becomes inefficient as n increases because it has make roughly n square by two comparisons. And now coming to the divide and the conquer algorithms, this is more elegant. It first sorts the point by which x coordinate, then splits the data into two halves. It recursively find the closest part in each half and finally checks if it's an ever closer pair that crosses a dividing line. This reducing the work dramatically instead of the dramatical growth. So I also printed a test example for which I used the n is equal to 20, which is n is equal to 10, m is equal to 10. To confirm both the algorithms return the same pair of the closest path. Now coming to the average run point, average running time of the time calculation. To perform the performance comparison meaningful, I didn't rely on the single run. I calculated the average running time over m is equal to 10 runs for each input size. This helps smooth out random variations due to easy load or background process. I use the Python time. I use time function to record start and end times that averaged from the input size of 320 and ending time it will be like 3330 points, showing it was the range of the several minutes. On the other hand, divide and the conquer. On the other hand, divide and the conquer algorithm stayed uh, the under the 20 seconds. Even for the 3330 points, showing a huge improvement, showing a huge point. So from which here are my results for the brute algorithm. For the brute algorithm, the runtime grew rapidly at the 5,000 at the 3,200 points. It already took a few seconds, and by the 3,200 points, it was a range of the several minutes. On the other hand, divide and the conquer uh, algorithm stayed under the 20 seconds, even for the 3,300 points, showing a huge improvement. I also calculate the constant C1 and C2, which represent the proportional constants in the theoretical model. T of n is equal to C dot n square by using the formula. And also I predicted, so here are the test cases where I will show you the execution, like the values, like how much time it is taking to execute. For example, if I say like three 500, and this will be like 3,600 and 400. So now when I run it, so this is taking like below the 20 seconds. So this is the test case which I can prove. And also now let's talk about the graph. In the brute force empirical, in the brute force empirical versus predicted plot, the curve rises trippy, almost exponential looking, confirming its quadratic growth. Now the divide and the conquer, however, it increases much more gently and aligned closely with its predicted n log n curve. Finally, the combined graph clearly shows the performance gap widening as n increases. The red line for the brute force shoots up, while the blue line of the divide and the conquer how stays relatively flat. So this visual comparison perfectly captures why algorithmic efficiency matters so for that of the large amount problems. Now, from this project, I learned how theoretically complicitly actually translates to real world performance. The difference between the 0 n square and the 0 n log n is not just the academic, it is massive in practice. Even though both the algorithms gave the same answer, the divide and conquer method saves enormous computation time as data size grows. So it also taught me how the distance fair experiments by keeping inputs consistent average over multiple runs and comparing both the empirical and the predicted performance using the proper constants. Now, overall, this experiment successfully demonstrate that the divide and the conquer approach scales far better and matches the theoretically 0 and log n expectation. So thank you for watching my presentation. I hope I gave a clear overview of the algorithms, results, and what I learned through the process.